In this, we will learn about what exactly is a fraction, how do we denote them, what are the different concepts that we can learn in fractions, how do we compare two fractions. All these concepts will be learned in detail. We'll just recall what all you have learned and move ahead. Now in this picture, what do you observe? This is something which everybody likes. Yes, this is pizza. Now, on your left hand side, you have a whole pizza. This is how it has been delivered, correct? In a box. But when I actually slice it into 6 parts, that is 1, 2, 3, 4, 5, 6. So when I actually divide it into equal 6 parts, each part is named as a fraction of the whole pizza, correct? It is a slice which we consider, and this slice is a part of the whole pizza itself. This part, this slice, is called as a fraction. So what is a fraction? Fractions are counting part of something. Something in the sense it could be anything. Now we are talking about pizzas. It could be chocolates. It could be any other item as such. So anywhere where you are actually considering only a part of the whole is called a fraction. Fraction, a word taken from Latin word fractus, means broken. It is a number that can represent part of a whole. As I said, it is a number that can represent a part, not exactly the whole thing, but a part of the whole item or the whole thing, whichever you are considering. Now, how do you express fractions? Now, to express a fraction as a part of a whole, we must divide the whole into equal parts. When an object is divided into a number of equal parts, then each part is called a fraction. I hope it is very clear now. See, what we are trying to express is a fraction is expressed as a part of a whole. It is not the whole thing as such, but it is just a part of the whole. And to express this part, what is the condition that we need to have? We must divide the whole into equal parts. We cannot just haphazardly divide it and say that this is a part of the whole. That cannot happen. So when an object is divided into a number of equal parts, then each part is called a fraction. And this fraction is related to a whole thing. Now, to correctly depict as to what I explained now, see, this is a part of a whole thing, correct? I have the whole circle is divided into 4 parts. Okay, this is exactly 4 parts, and now this part is called as part of the whole. What is the whole one? The whole one is the circle. So actually just one part of the 4 parts which we have divided is considered here. It is just a piece of a whole, and the other 3 parts out of 4 parts is remaining, correct? Now I hope all of you have understood. Shall we move on? Now, for examples, children, you might have seen these kind of fractions available everywhere. See, your birthday cake for that matter, if you can divide it into 12 parts, because you have so many people sharing it, correct? So if you make it so many parts and just one slice out of it, you just take one slice out of it, what is that is remaining? 11 parts out of 12, because you have taken one. Similarly, if a pizza is divided into 8 parts, then one part is what is being shown, so 1 by 8. Now again here, if you have 12 pieces, then these are the representation. This is how it has been represented. Here I have a kiwi fruit, wherein I have one whole fruit here and another half. So it is represented as 1.5. That is also a fraction now. Now here an apple is represented as one whole is there, so that is the reason I have 1 here. Then this is 2 by 10. I have made 10 slices of another apple, and I have just represented, or I have just shown 2 slices here out of the 10 slices. Okay, this is how even in clocks we find the fractional representation. See, as we discussed earlier, fraction names a part of a whole. For example, if you take this square slab, which is actually divided or which is actually having 10 parts here, okay, sorry, 100 parts here, then each part, if it is shaded, I just count this and it makes up to 75 parts being shaded. Okay, 75 squares being shaded. If you observe, this is this, if I consider as 1, 2 and 3 parts out of 4, correct? If I consider it as 1, 2, 3 and 4, this is 4, and 3 parts are shaded out of 4. Similarly, if this is a whole pizza as such, again each part becomes 1 by 3 if I divide it into 3 parts. Here again another an item being divided into 4 parts. So each one becomes 1 by 4. So here a donut being divided into exactly half, so it becomes 1 by 2. Here a corn being divided, this is the whole corn, and it is being divided into 3 parts. So each part can be represented as 1 by 3. Similarly, a biscuit can be divided, if it is divided into 4 parts, each part is divided, is represented as 1 by 4. Similarly for this candy, okay. Now for a small practice as such, how do you represent this? The slice which has been taken out of the whole pie which has been prepared. Okay, now how do you represent this? Can you try? Totally how many slices have been made? If I consider this as 1, 2, 3, 4, 5, 6, 7 and 8. So there are totally 8 pieces, 8 slices that are done, and out of that 1 is taken out, correct? So this can be represented as 1 by 8. It can be even written as like this or like this. So 1 by 8 is the fractional representation of this diagram. Understood? Now shall we move on? These are not difficult concepts, but if you work along with me, it's easier for you to understand. See, as we mentioned, fractions cannot be mentioned, or it cannot be represented if we don't have equal parts. If we don't have the whole item being divided into equal parts. Here, this is a representation which you will always find, which is half. Okay, half is nothing but one of 2 equal parts, correct? See, everywhere in the 3 figures what I have it here, be it a triangle, circle or a rectangle, I have 2 parts here, correct? The whole thing is divided into 2 parts, 2 equal parts, and even the circle for that matter, it's divided into 2 equal parts. Even the rectangle is divided into 2 equal parts, that is 1 and 2. So in this, how are we representing the fraction? Out of the 2 parts, 1 part is shaded. Got it, children? Out of 2 parts in a circle, 1 part is shaded. See, these are the 2 parts, correct? Only one part is considered. out of these two parts, only one part is considered. Both are equally divided. But we are considering only one part. So then we represent it as half. Now this one as well. We have 1 by 3. Here 1/3 or 1 by 3 is represented as, if you can understand it, the whole thing is divided into 3 parts. Correct? 3 equal parts, and out of that I am considering only 1. So that is the reason I represent it as 1/3 or 1 by 3. Here again in the triangle also 1, 2, 3, 3 equal parts. So that is how I represent it at the lower bottom. Now out of those 3, I am considering only 1 part. Then it is represented as 1/3 or 1 by 3. Even with circle as such, we have 3 parts, but out of that if I consider 1, it is represented as 1 by 3 or 1/3. Now moving on, quarter. 1 part of 4 equal parts is called as a quarter. Here I have 4 equal parts being divided. The whole one is divided into 4 equal parts. That is 1, 2, 3, 4. And out of that I am considering only one of them. So that is represented as 1 divided by 4 or 1/4 or a quarter. Again in this triangle I have 4 equal parts. If I am considering only one out of these 4, then again it is represented as 1/4 or quarter or 1 by 4. In this circle as well, I have the circle divided into 4 equal parts. Then if I want, or if I am considering only one part, then it is represented as 1 by 4 or quarter or 1/4. I hope all of you have understood, children. Similar to this, the representation goes in the similar manner. Like for example, if it is 1/10, that is, I have 10 parts here. If you observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of this, I have just one part being shaded, correct? I am considering only one part. So that is represented as, can you all repeat? Can you all tell me? Yes, 1/10 or 1 by 10 is the fractional representation. If the whole thing is divided into 100 parts, 100 equal parts, and one part is considered, then it is called as 1 by 100. Similarly, if it is into 1000, if the whole part is divided into 1000 and just one part is considered, then it is represented as 1 by 1000 or 1000th. Children, whatever we discussed now is represented in a tabular column for your easy understanding. Okay. See here, the whole is represented as 1. That also can be represented in a fractional form as 1 by 1. Then coming to the exact half we have learnt. Okay. This is represented as 1 by 2 because we have divided it into 2 parts and we are considering only one part out of it. So that is called half. Then 1/3 or 1 by 3 is when you actually divide the whole part into 3 equal parts. Now 1 by 4, similar to what we have learnt earlier, is a whole thing divided into 4 equal parts and then only one part is considered. It is represented as 1 by 4. 1 by 5 for 5 parts and 1 part being considered, and 1 by, similarly if we go on, it is 1 by 6, 1 by 7, 1 by 8, or in fact if you have to write in words, you will be writing it as 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9 and 1/10 of the whole part. Now it's a similar representation of what we have learned. See, 3 by 4 is what can be represented here, because there are 4 blocks. If you observe this first figure, there are 4 blocks. You can even check with your textbook. Out of the 4 blocks, if I consider it as 1, 2, 3 and 4, I have 3 parts shaded. Okay, 3 divided by 4. So 3 parts shaded out of 4. Similarly, we have another figure here. 1, 2, 3, 4, 5, 6, 7, 8. So out of 8 parts, only 7 is being shaded. Okay. Now, since 7 is shaded, I write this fraction as 7 by 8. Now, we can even consider fraction as a part of collection. Till now, we have learnt as a fraction as a part of a whole thing as such. But this whole thing can be a collection of a few things. For example, in the first figure, we'll just take up this example. See, I have 6 squares here, correct? 1, 2, 3, 4, 5, 6. Or else, if I consider this whole block as one part, exactly half is being shaded. Exactly half of this collection is being colored or shaded. So how do I represent it? Half out of how many squares? 1, 2, 3, 4, 5, 6. Out of 6 squares is being shaded. So what is the fractional part that I get? What is the fraction that I get? See, out of, in the sense I am multiplying it with 6. Half of 6 is equal to how many times? 6 divided by 2 is how much? 2 ones are 2, 3 times. Okay, so 3 is the answer that you get. That is, 3 squares have been shaded out of 6 squares. Did you understand how to calculate, children? Now we'll take up another example as well. The second example. Now here, if you see, I consider this whole collection as divided into 4 parts. Okay. And each part is having 2 circles. So that I name it as, how many collection of items, a collection of circles do we have? 1, 2, 3, 4, 5, 6, 7 and 8. Now the whole square or the whole rectangle, the whole thing is divided into 4 parts. So out of this, I have just 3 parts shaded. Did you observe? I just have these 3 parts shaded. This one is not shaded yet. So how many parts do we have? Out of 4 squares, I have only 3 squares shaded. So 3 parts out of 4 are shaded. And how many do we have? What is the collection of items that we have there? 8. Okay, out of 8 items. Okay, now again the same way as we did it, 3 by 4 into 8. What do we get there? Now 4 1 times and 4 2 times is 8. So the answer is 3 into 2 divided by 1, or I can even skip it off. 3 into 2 is equal to 6. So 6 parts are shaded. Are we finding 6 parts here? 1, 2, 3, 4, 5, 6. Now, okay, we'll take up another example. Children, if you do it along with me, you can also learn. You can just have the pictures in the textbook and refer if you are not able to get it in this picture. Otherwise, you can even follow it. Now, we'll take up the third example. Now, here the whole part is divided into 3, and each part has this, we can name it as 1, 2, 3, 4, 5, 6. So totally 6. Out of these 6 items, I have 2 by 3 items shaded, right? So 2 by 3 is being shaded. If you observe, see, just 2 parts out of 3 parts is being shaded, correct? So 2 by 3 out of how many? 1, 2, 3, 4, 5, 6. 2 by 3 out of 6. Again the same way. 2 by 3 into 6. So this is 3 1 times, 3 2 times. 4, you can cancel it. Okay, 2 2s are 4. So 4 parts is being shaded here. Did you get it? Okay, then we shall move on, children. Now, since we have understood how to represent the a fraction as such, or how to read a fraction when it is presented to you, now we also need to understand as to how can we represent any item for that matter in fractional form. For example, here in the picture, I have a set of toffees, a collection of toffees here. These look very much similar to the ones which we get, the gems as such. I hope all of you have consumed it. You have all enjoyed eating it. Now, this brand is called as Smarties. So, Smarties come in different colors. We have blue, yellow, pink, purple, orange, brown, red, green. So I have just tried to list all the number of toffees of different colored toffees here in the list, because they are not equal in number. For example, blue is 4 in number, yellow 3, pink 3, purple 6, orange 4, brown 5, red is 6, and green is 2. But total number is 33 toffees. So we actually have totally 33 toffees. Out of that, these are the different colored toffees which we have. Now, if at all I have to represent the blue Smarties in fractional form. Now, what would be the representation? See, blue is available in 4 number, that is 4 out of the total Smarties that we have, which is 33. So I represent the fractional form of blue Smarties as 4 divided by 33. Now, if you understand it properly, there is a dividing line. Okay, this is the dividing line between two numbers. This on top is called the numerator. Then this at the bottom is called the denominator. understand it clearly, we can even write it as numerator, the dividing line, and the denominator, which is the fractional form of any number. I hope all of you have understood, children. The number on top is called the numerator. The number at the bottom is called the denominator. Now, what is a numerator? Now, what is a numerator? Numerator, it is the number that is above the fraction line or above the dividing line. The numerator tells us how many such pieces are to be considered or are being considered. For example, I have, again, we are taking lot of examples of pizza now. Don't start demanding that you need to eat one. You can enjoy after all the pandemic scaring episodes are over. Okay, children. Now, if I take this as an example, it's the whole pizza, and I have divided into 4 equal parts, and I am considering I'm left with 3 parts out of 4 equal parts. That is 1, 2, 3 and 4. Okay, out of 4 equal parts, I'm considering 3 parts out of 4. So this is represented as, that is 3 divided by 4. 4 are the total number of pieces that the whole thing can be divided into, and 3 is the number of pieces that are considered. That is called as numerator. Understood? It is the number above the fraction line. Any number that is represented above the fraction line is called the numerator, and it represents or it tells us as to how many pieces are to be considered. Now, what is denominator? Denominator again is the number below the fraction line. So denominator is the number below the fraction line. It tells us about it tells us as to how many pieces the whole is divided into. See, as we discussed earlier, the fraction can be represented only when the whole thing is divided into equal number of parts. Correct? The whole thing is divided equally into different number of parts. It could be 4, it could be 6, it could be 8, depending on the size of the item as such. But here, the denominator usually represents as to how many pieces the whole is divided into. Here, the same example, the number of pieces the whole thing is divided into is 1, 2, 3 and 4. So it is totally divided into 4 equal parts. That is represented as the denominator, and it is written at the bottom. That is, it is written below the fraction line or the dividing line. One more important thing, children, is this number can never be 0. So if I have a whole, for example, if I have a whole chocolate, I cannot be considering that as 0. It has to be some number. So denominator can never be 0. That is the important thing that you need to always consider. Now, as we said, we will just learn as to how can we form fractions out of whole. See, we have learnt that a fraction can be possible only when we divide the whole thing into 2 parts. For example, 2 parts or equally into different number of parts. See, in this first figure, I have a triangle. So, in what ways can I divide it into equal parts? See, I can actually divide it exactly into half. Correct? So, this is one part, and this is an other part. Correct? If I am considering only this part as such, then I will represent it as 1 by 2. That is, out of 2 parts, 1 and 2, I am considering only one part, which is this one. I hope all of you have understood, children. So here I have separated, or I have divided into 1, 2, 3, 4, 5, 6, 7, 8. So I can divide it equally into 8 parts. So out of this, if I have to consider, I can consider it as, for example, if I am considering one part, then I would be representing it as 1 by 8. 1 part out of 8. Understood, children? Next, if I consider it as, consider 2 parts or 3 parts, okay, then it would be 1, 2 and 3 out of 8 parts. So 3 divided by 8. Now again, if I consider one more, correct, it becomes 4 divided by 8. I hope all of you have understood, children. So 4 divided by 8 is nothing but half. You just check out in this figure also. I have shaded 4 parts out of 8. 4 is exactly half of 8. Correct? Now considering the third diagram, this is a square. Now we have divided the square into 1, 2, 3, 4, 5, 6, 7 and 8 parts again. Okay. Here I have, I don't consider it, here I have 8 equal parts and I can consider any one of them. So 1 again becomes 1 by 8. If I consider 2, it becomes 2 by 8. Then if I consider 3, and this becomes 4, this becomes 5. So totally I have had 5 parts shaded out of 8 parts. So this is how you equally divide a figure. Okay. Now moving on to some practice problems. Children, all of you have your textbooks with you, right? Now we can consider solving from the textbook itself. You have exercise 5.1 on page number 55. Which of the following figures have been divided into parts of the same size? This is the first question that you have got. You have 4 figures here. So out of these, you need to find out the figure which is equally divided. See, considering the first one is not equally divided. All these 4 parts are not divided equally. So this is not the option. Now this, considering the second figure, it is divided into 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts and 4 parts are shaded. So this is the fraction, or this figure is divided into parts of equal size or same size. Now considering the third figure. Now the whole circle is divided into a curved partition, but that actually divides both the figures into equal parts. So this also can be considered as a figure that has been divided into parts of same size. Again, considering the fourth figure, is it divided into equal parts? No. The inner circle is not equal to the outer circle, correct? So this also need not be considered. So what is the answer? So answer is figures B and C are divided into parts of same size. Correct, children? Did you understand? So B and C are the figures that are divided into equal parts. Okay, shall we move on? Now for the second question. Draw a line to divide each of these figures into the required number of equal parts. They have actually given you how many parts you can divide it. So it's easier for you. You don't have to check it up. Now for this first one, it can be divided into two equal parts. This is how you need to draw the lines here. Now the second figure is you are asked to divide it into four equal parts. That you can very well do it. I can just give you suggestions that you can divide it horizontally and vertically. Then you will get equal parts. Now the third problem also is easy to draw into 6 parts. Now the fourth one is being asked to divide into 8 equal parts. For that we can actually divide like this. Okay. Now I have got 1, 2, 3, 4, 5. Now if I divide okay. Now if you find out, this actually is 1, 2, 3, 4, 5, 6, 7 and 8. You have got 8 equal parts out of this figure. Children, I want you to try the second and the third one as an assignment. Moving on. The third question, write each of the following as a fraction. To start off, the first one, how can it be represented? Half? Yes, 1 by 2. The second one, 2/3. 2/3 is represented as 2 by 3. I can write there itself. It is represented as half. This is 2 by 3. Okay. Then 2/10. See, the second number, whatever is being represented in words, is always the denominator. So I can write it as 2 by 10. Okay. Now 5/7 is nothing but 5 by 7. 5/16 is nothing but 5 by 16. Okay. Now 5/12 is nothing but 5 by 12. 8/9 is nothing but 8 by 9. 4/9 is nothing but 4 by 9. And 3/4, as we all know, is nothing but 3 by 4. 2/5 is nothing but 2 by 5. Children, I have written almost 5 denominations here. I want you to write the other 5 on your own. Now, as we wrote all the fractions which were given in words in terms of fraction, now we will have to write these fractions which are given here in terms of words. Like in words, how do we write it? So first one is 2 by 5 is written as, can you just try? 2/5. Correct. Can you all try along with me? Yes. Next, 3 by 4 is nothing but 3/4. Next one, 7 by 10 is what is being given here. So how do we write? Yes, 7/10. Okay. Next, fourth one 11/12. Fifth one is 2/3. Okay. Children, I want you to consider the other five, that is F, G, H, I, and J as assignment. Now, considering the fifth question, we have already discussed this, but again, it is there in the textbook. What fraction of the figure is shaded? Now, we have these figures, 6 figures mentioned here. The first one, we need to write how many fractions is it been shaded, or what fraction of the figure is being shaded. In this, if you consider 1, 2, and 3 equal parts being divided, the figure is divided into 3 equal parts, then 2 out of 3 parts is being shaded. Similarly, here if you consider 1, 2, 3, and 4, 2 parts out of 4 is being shaded. You need to first, children, it's always better to actually number it, like 1, 2, 3, 4, 5, 6, 7, 8. When you number it, you actually know how many parts it is equally divided. And out of that, whatever is shaded, you can write it down. Say, for example, here 1, 2, 3, 4, 5. 5 parts are shaded out of 8. Okay. So this becomes 5/8. Okay. The other 3 figures are considered as assignment. Now, moving on to fill in the blanks. That is, 6th question is fill in the blanks. The denominator of the fraction 1/8 is, which is the denominator you need to write. Okay. This is the assignment. The numerator of the fraction 2/5 is, I know you all know this. Okay. Try all these answers. It's very easy. 3 is the dash of the fraction 1/3. What is it called? What is this 3 called? What is the position called? Okay. 1 is the dash of the fraction 1/5. Next, in a fraction, the denominator is written below the dash separated by a line. What is the denominator written below? What is the name of the number that is given, which is written below the, the denominator is written below the particular number. What is the number which is written on top called? Now, write down the fractions or a fraction of the colored portions in these figures. Now, as we have discussed, see, out of these figures, like 1, first number it, it's always better. Out of 5 parts, 1 part is being shaded. So, the fraction is 1/5. Okay, out of 4 parts, the 2 parts are shaded. So, 2/4. Or it could be even written as 1/2. Now, similarly, you have 3 more figures which you will have to consider it as assignments.